All right, welcome students. We're going to have an online lecture to replace our class from Wednesday. We're going to do 4 problems from the notes. And you can see we're on page 13 right here. So we're going to start off on that page. We're going to look at number 3. Carl is the beneficiary of a $29,000 trust fund set up for him by his grandparents. Under the terms of the trust, he is to receive the money over an 8-year period in equal installments at the end of each year. If the fund earns interest at the rate of 8% per year compounded annually, what amount will he receive each year? Okay, so this $29,000 trust fund, that's a present value amount. That's how much is in the account right now. And he's going to take the amount out in 8 installments, and the future value will be 0 after he's received all the payments. All right, so let's do the app. The N is 8 years. I is 8%. The PV we said was $29,000. However, somebody had to deposit that money into the account. So money going in to the bank is negative $29,000. Okay? The payments that he will be receiving is what we're trying to find. The future value will be 0, and the PY and CY are both 1 because these are at the end of each year, once a year. And when you solve that, alpha solve for PMT, you should get 5,046.43. Don't forget your $sign out in front. Now notice this is also possible to do using the formula R equals P. This is the P, 29,000. When we use the formula, we don't put any negatives in. So P, present value, times I, all over parentheses, 1 minus 1 plus 0.08 to the negative 8 power. And you should get that same number right there. This is how much he will get annually for 8 years. All right, 8 times 5 is 40,000, so he's doing really well. That's an 8% interest. He's made about, more than, let's see here, $11,000 in interest. So that'll be great. Now, notice this is the same annuity formula that you would use to find the payment on an automobile or a mortgage, okay? It's the R equals P formula for present value. Now let's take a look at the Sandersons, number 4, who are going to refinance their home. The outstanding principal on their original loan is $150,000. That's how much they owe, with 240 equal monthly installments remaining at an interest rate of 8% per year compounded monthly. The new loan they expect to secure is to be amortized over the same period at an interest rate of 4% per year. So the only thing that changes is the interest rate. How much less can they expect to pay over the life of the loan in interest payments by refinancing the loan at this time? All right, so now we've got N equals 240. I is 8. PV is the amount of the loan, and remember, PV when it's a loan is always positive because the institution is giving us that money that we use to buy a house or a car. The PMT is what we're trying to find. The future value after we pay off all the payments is 0. And this time the PY and the CY are 12 because we're paying this in monthly payments. And so if we put alpha solve and find this payment, you should find that house payment is $1,254.66. Now, what about the new payment? Everything stays the same. The only thing we do is we change the I to 4 and then recalculate. And the new PMT And when you find this PMT, it will be negative because we're paying it to the bank. It comes out of our pockets, but we don't write down a negative. We write down as a positive. So when we do that, we will get 908. Whoops, let's try that again. 908.97 as the new amount. And so we want to know how much less can they expect to pay over the life of the loan. All right, so let's find the difference between those two numbers. 1254.66 minus 908.97. And then we'll have to multiply that by 240 payments. So this amount, this difference is all interest. All right, they're going to pay off the $150,000 either way. So the only difference in these two payments is the amount of interest that they're saving each month. And then when we multiply that by 240, you should end up with $82,965.60. That is a very large savings. Okay, $82,965.60 saved. Quite a bit of money on a $150,000 loan. Now, on your WebAssign, if you have any trouble with numbers like this working out, I recommend that instead of rounding, excuse me, to the nearest cent, take all your numbers out several decimal places, find the difference, and then multiply by your number of months, and that may make a difference. All right. Let's talk about credit card debt next. Number 5, you have a $4,000 credit card debt, and you plan to pay it off through monthly payments of $100. If you are being charged 18% interest per year, how long to the nearest month will it take you to repay your debt, and how much is the total of all payments? Now, most people have credit cards, so this is a good thing to go through. And so let's see if we can do this. Our N is what we're trying to find. Our I is a very large rate of 18%, and that's pretty standard for credit cards. If you can get a lower rate, then that's great. Present value. Anytime we have the loan, the present value is the amount of the loan. This is $4,000, and we have put that in our pocket and then spent it on something, so that's positive. PMT, how much are we paying? We're paying $100 a month, so that is going out of our pocket and going to the credit card company, so it's negative. And the future value after we paid everything off is 0. We're doing this monthly, so PY equals CY equals 12. And we're trying to find the N. Now, when you do this, it won't come out to a nice whole number. It will come out to something like 61.5. And so it says to the nearest month, and anytime that's a 0.5, and 5 or larger, it rounds up. So we're going to say 62. And since we're doing this 12 times a year, that's 62 months, or 62 payments. And 62 months, that's 5 years, which is 60 months, and 2 months. Okay, but I'm just going to write 62 months, and you'll have to be careful in WebAssign which one it asks for. Now, how much is the total of all the payments? Well, we're going to be paying $100 a month times 62. So $6,200 is the total amount that we will end up paying for that $4,000 credit card debt. So we have paid about $2,200 in interest Again, that 18%, even though it's only over 5 years, we've paid quite a bit in interest. All right, now we did the arm in class. And so what we'll do is we'll stop here, and the next page has a problem for retirement, and I will do that in a separate video.